Hello guys, welcome back. I hope you're making progress with your statistical analysis. Today is the day we're going to learn how to build an SEM, a structural equation model, step by step in R. The example and the dataset that we're going to work with today is the same example of the previous video. The video that we talked about perfectionism and procrastination and to see if they're connected. Here is the link to this video in the right top corner. You can see that video first if you don't know what it is about. And also here's the summary of what it was about. But I really suggest that watch that video first because we covered everything there, from the full explanation of the research, what is SEM model, when and why to choose it, and saw the final results of the research question. So anyway, get back to the summary here. We have a small data set of 93 students. We have their GPA scores, their scores for the type of perfectionism that is in the questionnaire, and finally the score that each of them got for their procrastination level. So the research question is, do different types of perfectionism affect the procrastination in students? And if there is any, we want to know if there are direct or indirect relationship within these types that also affect the procrastination level. So we want to look at the whole picture, not just a predictive relationship. That's the main reason why we chose SEM for this research question and this data set. Again, we have got this covered completely why we chose SEM, not any other technique in the previous video. So go ahead and check it for yourself. Okay, let's get started on the analysis. First, as always, see what packages we need. For this example, we're gonna need tidyverse for data manipulation, psych for descriptive stats, mean, standard deviation, skew, and kurtosis. Or you can use the stats. And interactions for regression and moderation plotting. And finally, lavaan and semPlot for the SEM analysis. Start with loading the dataset. setWD means setting working directory. And you are supposed to write the path that your dataset file is in these parentheses. Then load the dataset using read.csv command and then name it, for example, data. Let's see the first 5 rows of each variable. So run it. You see GPA, self-oriented, socially prescribed, and other-oriented perfectionism, and also the grades for procrastination for the first 6 rows. Next step is descriptive statistics. Run it, and as always, look at the console window. You see we have the number of observations for each variable, n, which is 93. The value of mean for each of them, the standard deviation, median, trimmed mean, which is a mean that is calculated after removing extreme values, usually the top and bottom 10%. MAD, median of the absolute deviations from the median. I know the definition might sound a little bit confusing, but simply it measures variability without being affected by the outliers. And skewness measures how symmetric the distribution is. So let's see each value of skewness means what. If skewness is greater than 0, it says that the data is right skewed, meaning that the tail is on the right and the graph is fatter in the left. It's also called positive skewness. If skewness is less than 0, it means that the data is left skewed. The thing that is called negative skewness means that the tail is longer in the left and fatter on the right side. And if the skewness is 0, it shows that our data is roughly symmetric. So based on what I told you, you see all the variables except for GPA are right skewed. But the good thing here is that they are not very far away from being symmetric considering the mean. And we get to the next one, kurtosis. It means how picked or heavy-tailed the distribution is. Kurtosis greater than 0 shows that we have heavy tails, meaning that there are more extreme values there. And as you can see, here just other-oriented perfectionism has them. And other kurtoses for other variables are less than 0, meaning that they have flatter distributions. And for your information, kurtosis of 0 says that they have a normal-like distribution. And finally, SE is the short form for standard error. A standard error shows how precisely your sample mean estimates the population mean. Lower standard error shows more precision. So it's an important factor. So in general, our data looks roughly normal and nothing unusual is happening. Now that everything is fine, let's just run the model. Our first model is a simple path analysis where the 3 perfectionism subtype predict procrastination. Then for the SEM model, we use the model and it'll give us the exact coefficients, extra outputs like the indices, standardized effects, and flexibility. I want to just clarify something. Even though this model is a simpler type of SEM, and as you can see, it's more like a multiple regression, we use the SEM model because it's more precise and perfect compared to multiple regression, right? So let's see the summary together. Here is the result for model test user model. The chi-square value is 0, so it's a perfect fit. And you also see the baseline model result. Then you see CFI or comparative fixed index, which is 1, and it is perfect because CFI greater than 0.95 is always good. And you can also see TLI or Tucker-Lewis index, which this one is also 1, and it shows a perfect fit too. Another important criterion are RMSEA and SRMR. RMSEA means root mean square error of approximation. So as you can see, it's 0 here, and it is perfect because RMSEA less than 0.05 is an excellent result. And the other one, SRMR, is a short form for a standardized root mean square residual. And it is also 0, and it is also perfect because SRMR less than 0.08 is good. Next code is for semPlot diagram. By this diagram, we will see the visual relationship between variables. So run it. And before going deeper, I want to talk about the anatomy of this diagram. In this diagram, boxes are for observed variables and circles for latent variables, which as you can see here, we don't have any latent variable here. And single-headed arrows like these from perfectionism to procrastination show hypothesized causal effects. And double-headed ones like these between perfectionism types show correlations. So I'm going to go ahead and explain each of these variables means what. SIO is a short form for self-oriented perfectionism. SCP is socially prescribed perfectionism. OTO, other-oriented perfectionism. And PRC, procrastination. So this straight arrow from SIO pointing into the PRC box, as I said, shows a standardized effect, which is 0.43. It says that higher self-oriented perfectionism is associated with higher procrastination, as we know from the results. And this is the only significant predictor. But the 2 other predictors have very small effects, as you can see by comparing the numbers on these arrows. Especially this one, OTO, other-oriented perfectionism, almost has 0 effect. Then we get to this number, which is under the PRC box, procrastination. is the unexplained variance in standardized form. So as we calculated before, R squared equals 0.19, which means that the three perfectionism types together explain about 90% of the variance in procrastination. You might say it's a small number, but actually this is very normal for psychological constructs. Now let's see the correlations among the predictors, and these are the dashed two-headed arrows between SIO, SCP, and OTO. The number for SIO and SCP is negative 0.02, which means almost no correlation. The correlation between SCP and OTO is negative 0.07. It is a very small negative correlation, and simply we can just ignore it. And the number for SIO and OTO is negative 0.05, which is also a very small negative correlation. So the final conclusion of this diagram is that the three types of perfectionism are mostly independent in our example. They do not form a strong perfectionism cluster thing at all, which explains why only SIO or self-oriented perfectionism predicts procrastination. Let's move on to moderation results. With the help of it, we're going to answer this question. Does GPA change the relationship between self-oriented perfectionism and procrastination? So we use centering for both of these variables, for self-oriented and GPA, because it makes interaction terms easier to interpret and reduces multicollinearity. Then we fit the model with also the interaction phrase, and then get a summary of it to show the results. So we first centerized them, then added interaction to the model. Run it, and here's the output. Here are the coefficients. For main effects, the coefficient for self-oriented perfectionism is 0.317, and the p-value is less than 0.01. So it's strong and significant. It also confirms that students with higher self-oriented perfectionism tend to procrastinate more. This matches the whole thing that we covered so far, the results from diagram and the model and the SEM results. The coefficient for GPA is negative 0.051, and the p-value is greater than 0.01. So the effect is not significant. Finally, socially prescribed perfectionism and other oriented perfectionism are not significant too. Right? Next, let's see the interaction. The interaction between self-oriented and GPA. The coefficient is negative 0.012 and p-value is 0.759, which is greater than 0.01. So we failed to reject the null hypothesis, meaning that the result is not significant. So there is no interaction between the GPA and self-oriented perfectionism. GPA does not moderate the relationship between self-oriented perfectionism and procrastination. In other words, the slope of perfectionist procrastination is the same for low GPA and high GPA students. And even if we plot the interaction, the lines will be almost parallel. And finally, R squared for this model is almost 0.24, meaning that the predictors explain about 24% of the variance in procrastination. You see, this is moderate for psychological data and is higher than our SEM model R squared, which was about 19%, I guess, because we added GPA and an intercept-based model, right? So now let's plot the interaction. We would expect parallel lines. Let's run it and see. And here it is, the plot. Let's see what these lines means. First of all, this plot shows the relationship between self-oriented perfectionism, x-axis, and procrastination, y-axis, at 3 levels of GPA. +1 STD of GPA, which is the dark solid line, mean GPA, medium dashed line, and -1 is the of GPA, the light dotted line. So as you can see, the three regression lines follow nearly the same slope. This directly confirms the statistical result that we got so far. Parallel lines say that the effect of self-oriented perfectionism on procrastination does not depend on GPA. Another point that we can capture from this plot is that all lines slope are upward, which means across all GPA levels, as self-oriented perfectionism increases, procrastination increases too. And that was it. That was all you needed to do to figure out this question. As always, my friends, I hope you liked this tutorial and found it helpful. If you did, please subscribe to my channel. This is very important for my channel to grow by you subscribing it, and like this video. I'll see you in the next video, and I gotta tell you, it'll be an exciting one. See you.